Hi there, welcome to Bitbee. My name is Tirupati Rao and I am an experienced web developer. Welcome to very first chapter of the first unit, that is machine learning basics. In our very first video, we have already covered the full roadmap for this course, that is machine learning for the beginners. If you have missed that introductory video, you can visit it by clicking the link showing here. I also provided the GitHub link for the full roadmap of this course. So coming to this chapter, we are covering two topics today, that is what is machine learning and essence of machine learning, and also we will explore about the differences between deep learning, machine learning and artificial intelligence. And before dying, just hit the subscribe button if you're not yet subscribed to Bitbee. Also please share the channel with your friends. It means a lot and it's a big motivation to us. Thank you. Now let's go through the topic. In our introductory video, we have already discussed that machine learning is a subset of artificial intelligence, which is a broader field. Machine learning works around the historical or training data. So primarily it works with the three components, that is data, statistical models or algorithms, and the output. So the main objective of machine learning is developing the model using existing data or training data sets, which will generate the desired output, and the output can be a prediction, or it can be a classification, or it can be a set of recommendations. So here the statistical model can be anything, that is logistic regression or a decision tree or a naive Bayes algorithm, anything. Generally, these models keep improving over the time through the training data. So let's explore few examples of machine learning so that you will be clear with the objectives of machine learning. Our daily applications like Netflix, Spotify and Amazon uses real-time machine learning to provide personalized recommendations to users based on their browsing history, preferences and behavior. ML also used for important applications like fraud detection systems in financial transactions. ML models also used very much in autonomous vehicles like self-driving cars. The ML models works around the data which is collected from the different sensors such as cameras, lidar and radar, etc. This real-time data along with ML models helps to detect objects, recognize road signs and react to changing traffic conditions. ML models also used for other applications like healthcare monitoring, natural language processing, that is Siri, Amazon Echo, etc. These are all very few examples I have mentioned here, but there are also a wide range of fields where the ML models were applied. So far we covered about machine learning and its applications in various fields. Now let's see what is deep learning and its applications. Deep learning field is again a subset of artificial intelligence. We can also say deep learning is narrow AI. We have seen that machine learning works around the statistical models. Similarly, the deep learning works upon neural networks. These neural networks are inspired by the structure and function of the human brain. Biologically, neurons are the fundamental building blocks of the human brain and nervous system. They are specialized cells capable of receiving, processing and transmitting electrochemical signals. In the same way, the neural networks will work for deep learning. You might wonder how it's possible. Yes, it is possible. Let's see how. Here I am giving you the overview at high level. Definitely I will make a separate video how the neural networks really work. Here in the diagram you can see the neural network consists of several layers. The first and last layer are input and output layers respectively, and all the remaining middle layers are called as hidden layers, also the black box of the neural network. Here the count of the hidden layers can be anything, it can be 2, 3 or 4, depends upon the model. Here the input for the neural network can vary based on the problem we are solving. That is, input can be a classification data or a numerical or categorical data or a sequence to sequence, depending on the what type of problem we are solving. Also you can observe here, once the input was fed to the input layer, at every hidden layer some of the neurons will be activated, and at the output layer one or more neurons can be activated. Finally, at output layer the activated neurons determines our output. To understand it clearly, let's take an example what is the input and what is the expected output. Before that, just remember the links between each layer are called as weights. These weights will have specific values. Similarly, each neuron carries some value. This value can be anything between 0 to 1. Generally, these activated neurons will have the value near to 1. So at each and every hidden layer, these values, that is 0 to 1, also known as sigmoid values, getting calculated using activation function along with weights. Okay, for example, if we are providing different images of cats as an input to the input layer and we'll ask neural network to identify the image, then it processes the images using the pixels and it calculates through these hidden layers and it will recognize and gives us the desired output. I'm reminding you once, I'm just explaining this at very higher level because understanding deep learning in depth is a different path. So for this, definitely I will make a separate video series. If you want to explore it more, I'm providing a link for an article. Actually, it's not an article, it's a book. You can go through that link and you will definitely get a very deep knowledge on neural networks and deep learning. So that is all about the deep learning. And now finally coming to the artificial intelligence, we know that AI is a very broader field where ML and DL are the subset of the artificial intelligence. So AI encompasses a wide range of techniques including ML and DL as well as other approaches such as symbolic reasoning, expert systems and evolutionary algorithms. So the objective of the artificial intelligence is creating the powerful systems that were capable of performing tasks that typically require human intelligence. So these systems can be used in various fields like manufacturing, medical, computer science, and so many other fields. So coming to the applications of AI, there is no limit. So that is all about in this video. We'll see you in the next. Thank you.